The topic for this lecture is LAN topologies and architectures. In this, we are going to cover two topics, that is LAN topologies and LAN architectures. So, the topologies and architectures in a LAN are the basic building blocks for designing a computer network. So, without these, it is very difficult to understand the computer network. So, what is meant by a topology? A topology is nothing but it is the physical and logical arrangement of nodes and connections in a network. So LAN topology is nothing but it is a collection of physical topology as well as logical topology, and it is arrangement of nodes. Nodes can be any of our networking components, and connections are nothing but the links that are there. They form up the complete computer network. So topology basically talks about the physical arrangement as well as the logical arrangement. So here we are talking about nodes, right? Nodes are nothing but they can be any type of device, like they can be switches, they can be routers, they can be any computer devices, it can be a software with switch and router features. And connections are nothing but the cables that are used to transmit the data. So there are two types of LAN topologies. They are physical and logical. So here if we look at this diagram, this is a physical topology. So what is meant by physical topology? A physical topology is nothing but it is the physical layout of the components on the network. Physically, how each and every component in the network is being arranged. That is nothing but a physical topology. Whereas coming to the logical topology, if you look at this particular picture over here, it will determine how hosts communicate, how the host will communicate across a medium. So here looking at the physical topology over here, if you can see, this is a you can imagine this as a uh, particular university, where in university there are several classrooms. This is classroom 1, this is classroom 2, this is classroom 3, and they are having systems. And in one particular system, in one particular classroom, all the systems are connected to a classroom hub. Like that, each and every classrooms systems are connected to a classroom hub. These in turn are connected to a switch, and this is the administrative office that is there. So administrative office will be having their own needs, and there also all the systems, administrative office systems are connected to another hub, and there is access to the mail server, web server, file servers. All of them are connected to one particular switch. So physically how they are arranged, that is meant by physical layout. So here we can say that uh, it is a physical arrangement. Over here if we see at the logical topology, each and every system is having its IP address. So how can one system communicate with another system? It is via these particular IP address, that is Internet Protocol address. So logical topology means it determines how the hosts communicate over a medium. This is your medium, that is these cables are your medium. So how is a message sent by a sender reaching the destination? It is only by the destination address that is there in the message. Is looking at the destination address only, uh, the particular message will reach the destination. So the two types of LAN topologies are physical topology, that is, it talks about the physical layout, whereas logical topology means it talks about how two hosts will communicate with each other across the media. So we will look at each one separately. Coming to the first one, LAN physical topologies. So as we have already seen the definition, it is nothing but the physical arrangement of all the components in a network. So this topology, it defines the way in which computers, printers, and all the other networking devices are connected. And there are different types of LAN topologies. This is very much important. There are different types of LAN topologies. So some of them are bus topology, ring topology, star topology, hierarchical or extended topology, and mesh topology. So here, if you can see, this is the diagram over here. So this is your bus topology, where you are having a particular cable and all the devices are connected. This is a ring topology. You can see a circular formation of all the devices. A star topology, a hierarchical extended topology, and the mesh topology. These are all the uh, physical topologies. That is, they specify the physical arrangement of all the networking devices. So if we let us look at each one in detail. So this is your bus topology. So in bus topology, as the definition says, devices are connected to a single cable called as bus. So this straight line is your bus. This cable is called as bus. That single line is nothing but it is a bus. And each and every device that is going to be in the network has to be connected to this particular bus. So here they are getting connected over here. They get joined to the particular bus cable. Each and every device that wants to communicate with the other devices has to get connected to the single cable called as a bus. And if you can see over here, there is a uh, at the two ends of the bus there are two uh, uh, things, that is, they are called as terminator. So this terminators, what they do is they prevent signals from bouncing back, and they cause uh, so by preventing them they are restricting the network error and. So whenever any signal, if it has not reached the destination, then and it has reached the terminator, that particular message will be uh, removed from the network. And whenever this happens, and when the destination has not received, again the sender will send the frames to the destination. So this, as I have told you, there will be a single cable, right? This cable can be a coaxial or a twisted pair cable. It can be a coaxial or twisted pair cable, and it will support up to 10 Mbps. This particular cable will support up to 10 Mbps. And this topology, it is mostly suitable for home offices or small businesses. So it is very much limited. And this type of topology, it is very simple to implement. And suppose if any, and one more thing is, it requires a lot of cabling, because any system, when if it has to connect to the network, it has to use its own cabling wire in order to join the bus. In the same way, if see, if at all any of this particular cable gets broken, that is, if this particular cable gets broken, then only this workstation will not work or will not communicate. But suppose if the main cable, that is the bus, if there is any crash in the main cable, then completely there will be a very much they say that there is a complete crash over the particular system. And over here, if we can see that the network traffic, if the network traffic is high, it increases collisions. If there is a lot of data that is being sent on the this particular cable, then there is a chance for collision to occur. And see, it is very much, as we have seen, only few hosts can get connected to this. If more number of devices or more new devices are being added to the network, then the data transmission speed will slow down. Next one is ring topology. So here if we can see the diagram. So in the diagram you can see that hosts are connected in a physical ring or circle. See all the hosts, here you have 4 hosts, 1, 2, 3 and 4. These are 4 hosts, right? All of them are connected with a physical ring, or it is in the circular form. And here the data flows in only one direction, whereas in the bus it is both directions data can be flowed, but here coming to the ring topology, data flows in only one direction. Here if you can see the arrow, it is traveling in only one direction. And in the bus topology we have seen terminators at the end, but since here all the uh, hosts, since they are connected in the form of a circle, there is no terminator over here. There is no beginning and there is no end. And coming to the working of this particular ring topology, in this particular ring topology, there is a special frame or a specially formatted frame, and it is called as a token. So here if you can see, this is called as the token. This is a frame. Frame is nothing but it is a it contains some data. So when now what happens is this token will be traveling around this particular ring, and whenever it comes across a host, it will stop at that host. So first if you can see, it has come to host number 4, it will stop over here. And when the host sees that a token has arrived, if the host wants to transmit data, then what the host will do, the host will add the data into this particular frame, as well as the host destination address will also be added to the frame. And once this is done, this particular token which is having the data as well as the destination address will go around this particular ring. It will go around this particular ring until it has reached the destination. Suppose destination is 1. The destination is 1, it will move around this particular ring. 3, destination did not match. 2, destination did not match. 1, the destination has matched. So then what happens, the destination, when the token has arrived, it will check with its address and it will copy the data that is there in the token. And once it has copied the data, again if it wants to send any data, it will fill the data into the token, or simply it will again pass the token forward, and the token again will be moving into in the ring. So that is about ring topology. And in ring topology, suppose if any of the cable, that is if the transmission media, if it crashes at one point, uh, data can flow through another uh, way also. Next one, star topology. So in this, if you can observe the diagram, if you look at the diagram, all the network components are connected to a central point or a central connection point. This is called a central connection point, and the central connection point can be a router, a hub, or a switch. So, like this, if we arrange the computers or the networking devices, then we say that it is connected in the form of a star topology. So, this is called as the central connection point. Central connection point. And all the here you have some computers and some additional devices that are connected. So how does all these networking devices connect? Each host on the network has a cable segment that will attach the host directly to the central connection point. So if this particular device wants to uh, get connected to the star topology, then with its cable it will get a connection between itself and this particular central connection point. So the main advantage of using the star topology is it will be easy to troubleshoot. That is, if there is any failure of the cable something, it will be very easy to troubleshoot. Why? Because here each and every device will be connected with its own cable to the central point. And if at all, if any of the particular cable or any of the particular device is not working, then that particular device only will be affected. Suppose if this particular cable is not working, then only this particular networking device, that is your desktop, will not be able to communicate with the rest of the devices. So it is not affecting the entire devices that are connected in this particular star topology. So that is a advantage. And when the problem arises is if the particular central connection point, if this particular thing fails, then the entire star topology will crash and not. And the next one is hierarchical or extended star topology. So here extended star topology, from the word itself you can understand. So here what is happening is, if there is a star network and if you are adding some more additional networking devices, then it forms a extended star topology. So actually, if you can see, this can be considered as one of the star network. But if you can see further, to this particular device, to this particular device, you are adding some more additional networking device. That is, here you are adding a hub, you are adding a hub and adding a hub. So it becomes a extended star topology. So for an initial star network with an additional networking devices connected to the main networking devices is called as extended star topology. So where is it basically used means, it is basically used in corporations, uh, in universities, in large networks like in companies. In those places, this particular hierarchical star topology is used. And the last type of physical topology is mesh topology. So, what is meant by mesh topology? It is nothing but simply connecting all the devices to each other. So, here if you can see, there are five systems. So, 1, 2, 3, 4, and 5. So, if you can observe, One should get connected with 2, that is, one is connected to 2 via this link, one is connected to 3 via this link, one is connected to 4 via this link, and one is connected to 5. So here uh, there are 5 devices, and each and every system will be connected to all the other devices. In the same way, even if you see at 2, 2 is connected to 1 via this link, 2 is connected to 3, 2 is connected to 4, and 2 is connected to 5. So every device is connected to every other device. And if at all any of the cable, suppose if this cable is a problem, it's not working, it will not affect the entire network. Like in the star topology, we saw that if the central concentration point, that is if it is a hub or a router, if that crashes, the entire system will crash. But here, even though if one cable is not working, it does not affect the working of the entire network. And this particular mesh topology is used in WANs, wide area network, that is interconnecting different LANs is nothing but wide area network. And the most common example is internet for mesh topology. But if you can see over here, this mesh topology is very expensive and it is difficult to install because a lot of cable has to be connected between each and every device. So up till now we have discussed that LAN topology is nothing but a physical arrangement of all the networking devices, and we have seen that there are LAN topology is divided into two types. One is physical topology, another one is logical topology, and we have seen what are the different physical topologies, that is, given the networking devices, how can they be connected. And not only being connected, we have also seen some of the advantages and disadvantages also. So what we have seen is bus, ring, star, hierarchical, and mesh topology we have seen. So next we are going to discuss about the logical topology. So basically logical topology is divided into two. One is broadcast and other one is token passing. So here, what is meant by broadcast topology? So broadcast means there will be a host and this host will be broadcasting messages to all the other hosts that are there in the same network. So it you can think as a some radio from the radio station, there will be transmission of the radio channel and all the people will be listening. So in the same way, broadcast topology means a host will broadcast a message to all hosts on the same network. So, and how the messages are sent means messages are sent on a first in first out for transmission of data over the internet, over the network. And coming to token passing, so token passing topology means here the concept of electronic token will be used. That is, electronic token in the network, they will be passing this electronic token one by one, that is sequentially to each host. Whenever a host will receive the token, it will send the data. If it wants to send the data, it will copy the data and the destination address into that particular token and send it to the and keeps it into the network. And the destination, when it sees the token, it will copy the data. So if the host is not willing to send any data, it will simply pass the token to the next host, and this particular process will repeat continuously. Coming to the next concept, that is LAN architecture. So what is meant by LAN architecture? You can say that LAN architecture is nothing but physical plus logical topology. I can say that LAN architecture is nothing but physical plus logical topology is called as LAN architecture. So there are basically three types of architectures. One is Ethernet, another one is token ring, another one is fiber distributed data interface. So these are the physical and logical topologies that are used in each and every architecture. So what is meant by Ethernet? So basically Ethernet architecture means it is based on IEEE 802.3 standard, and this particular standard will be using a method called as CSMA bar CD. That is, its full form is Carrier Sense Multiple Access Detection. Access collision detection. So basically, when transferring data over the transmission media, this particular CSMA bar CD plays a very major role. And Ethernet will be using a logical bus or a broadcast topology. It will be using, and sometimes it may also use bus or star topology. And this particular Ethernet, its standard transfer rates are 10 Mbps and 100 Mbps. But nowadays, due to the advancement in technology, it has expanded to 1000 Mbps. And the next one, token ring. So token ring is also one type of LAN architecture, and it is based on token passing. Token passing is used as the access control method. Previously, we have seen that carrier sense multiple access collision detection is the access control method that they have used. But in this particular token ring, token passing access control method is used. And this token ring is used in computers and mainframes. And this token ring uses a star wired ring. Star wired ring anamata. And here, if we the outward appearance of the network design appears like a star. Okay, and but actually what is happening is in this particular central hub, whichever is there inside the device, the wiring will be it forms like a circular data path. So that's why it is called as star wired ring. So actually there will be a hub and several devices are connected, so it appears like a star, but actually inside this particular device there will be a ring connection. So over here again tokens will be passed. First the token will reach here. If the particular system does not need it, it will come to the next one. So internally it is there. So this token ring topology is called as a star wide ring thing. And the computer, it is connected to a central hub. In this particular type of architecture, that is token ring architecture, this particular central hub or the central connection point is called as MSAU. MSAU, that is multi-station access point. And the last LAN topology is FDDI, as we have seen, and it is also a type of token ring network. Basically, FDDI, it will be using fiber optic cable. Fiber optic cable means it is a cable in which the transmission medium is a glass or plastic. Okay, and this particular FDDI, it combines with high speed performance, and also it will be using the properties of token ring, token passing ring topology, so that it can transmit the data at a higher rate. It is used to connect several buildings or office complexes, and also in university campuses this particular LAN topology, that is FDDI, is being used. So here this FDDI, it uses a dual ring and it supports up to 500 computers per ring. So you can connect 500 computers in a ring topology. Thank you.